Good? All right, everybody. This is my friend Mez, and he's here to talk to us about wearing the brain and like how it might impact security. Okay? Yeah, I guess.
Awesome. Thanks, Ryan.
Can you guys hear me like this?
It'll come out better on it.
Okay, does it actually get recorded off this?
Okay.
Cool. So I'm Ramez Naam, aka Mez. Thank you, Ryan, for inviting me here. I'm going to talk about my novel Nexus and really the science behind it. Among other claims to fame that might be relevant to you guys, I worked on the object model of Outlook. So I think I'm probably partially responsible for more viruses on the net than most people, let's say, or as I like to think of it, as new life forms evolving in disease. This is a novel about, it's a science fiction novel. It's set in 2040, which sounds far in the future, but it's as far ahead of us as 1985 is behind us. It's really not that far. The premise in the novel is there's a drug you can take, you swallow it, and it attaches little nanodevices to the neurons in your brain and broadcasts what they're doing wirelessly. And if somebody else has the same things in their brain, you become, Corey Doctorow called it weakly telepathic in his review. And my protagonists are grad students in San Francisco working on improving this tech, building apps on top of it, boosting the range. They're busted by evil government agents, blackmailed into going to Thailand to spy on a Chinese scientist, and then bullets start flying. So this is definitely science fiction, but it's as much as possible, the science in it is real, and it's based on research I did for a previous book called More Than Human, which is about the actual research into human augmentation, making people smarter, stronger, longer lived, et cetera, et cetera. So we've seen this idea of linking brains to computers in sci-fi before, right? We've seen it in the Borg, Star Trek, where brain linkage leads to a superorganism that suppresses individuality and wants to control the galaxy. We've seen it in The Matrix, where the great American philosopher Keanu Reeves says, "I know Kung Fu." We're able to beam it straight into his brain. But lately, there have been people talking about this not in terms of science fiction. Larry Page said, you can imagine being augmented by Google, where you think about what you want to know, and Google would whisper into your ear the answer. Right? Sergey said that he wants Google to be the third half of your brain, which is kind of awesome. I want like 1.5 brains. You have a bumper sticker in your car that says, "My other brain is the data center." Of course, we all know that Sergey is on his way to being a cyborg anyway. So what would it be like to have a system like Google wired into your brain? Or to have a Facebook, or a Twitter, or even just a peer-to-peer communication system in your brain? Well, program management is my background, so think about the requirements. I just write the spec, you guys can implement. And the spec says, we have to have data input into the brain. We have to have data output to get data out of the brain. We're probably going to have to do some signal encoding and decoding, because the way the data is represented in your brain is probably not in JPEG for video or whatever you have. Multiple data types, text, audio, video, and of course, safe, deployable, and secure. And as we'll talk more about, these might be the very biggest challenges of this kind of tech. All right? So is that all science fiction? Well, some of it is actually happening today in a very, very low fidelity, low bandwidth way, but it's getting better. Pretty quickly. Why is it getting better? Is it getting better because we're investing in cyborg technology to create the superhumans of the future? Mostly not. Mostly it's getting better for medical applications. That's where the R&D is. The motives are large. There's about 20 million deaf people in the US. 2 million of them, hearing impaired people, not all of them are fully deaf. 2 million people have some form of sensory neural deafness, which means the inner ear hair cells are dead. And those cells are what turn the vibrations that are sound into nerve impulses in your brain. If those are gone, a hearing aid cannot help you. So all a hearing aid does is filter the sound, get rid of the background noise, and then take the cleaned up signal and broadcast it louder as sound into your ear. If you have no inner ear hair cells, it doesn't work. 1.3 million blind people in the US alone, almost 30 million blind people worldwide, 2 million paralyzed people in this country, 1.5 million with Parkinson's, and 5 million with some sort of negative impact on attention, memory, personality, due to everything from a concussion to something more traumatic. This picture is a cross-section of the skull of Phineas Gage, who's the famous person who had a railroad spike shoot through his skull and out the other side, and he lived. He lived on, but he changed radically. His personality shifted dramatically, his memory was all wobbly, he went from being a very mild-mannered person to being kind of a jerk, is what we're told, quite long ago. Okay, so at least 10 million patients in the US that could benefit from this, and actually about 250 million worldwide is the number that we're looking at. Okay, so that's the motive. What are the means? Well, the means are, we know that the brain is an electrical system, it's electrochemical. We've known that since 1870, actually, when these two guys, Fritsch and Hitzig, they were scientists, kind of young scientists at the University of Berlin. They had an experiment they wanted to do to prove that the brain and the nervous system were electrical. The University of Berlin thought it was crazy, crackpot idea, wouldn't give them any resources. So they used Hitzig's dining room table, they knocked out a dog, and they electrically stimulated parts of its brain and could show that they could cause its paws to move at will by doing this. We learn much later that it's not just movement, but it's actually thinking and feeling and perceiving are electrochemical. Because of this guy, Wilder Penfield, he was kind of one of the fathers of neurosurgery, and one of the things that he did is he operated on epileptic patients. So back then, as somewhat is still true today, one of the last lines of defense for epileptics is what they call ablation. What that means is brain surgery to destroy the part of the brain that is sending out the aberrant signals that are causing the seizures. So Penfield would do this surgery, but he wanted to do the least amount of damage to his patients possible. So he would have them awake on the surgical table with part of the skull off, and he would electrically probe parts of their brain. When he'd find the one that caused a seizure, they would have a seizure. That way he could remove just that part and leave everything else alone. But as he did this, he found that if he stimulated some parts of the brain, his patients would suddenly have a waking dream, or would say that their world turned red, or that they suddenly smelled something, or they suddenly felt sad or happy. So Penfield was the first guy to say, hey, look, it's really obvious in my experiments, in my surgeries, that it's not just movement, it's thinking and feeling and emotions and all of this is also impacted by electricity in the brain. From there, things got very weird, as they did in general in the 60s. Two guys, Robert Heath and Jose Delgado, the latter of them actually funded by the CIA under a program called MK-Ultra, where a lot of urban legends have come from, but some of it actually was true. These guys did experiments on controlling the behavior of animals and then humans via implants that electrically stimulated the brain. So in animals, they demonstrated that they could knock an animal out or wake it up with an impulse to the right area of the brain. They could make it hungry or satiated. They could make it aggressive or passive. They could stimulate the pleasure centers and make it crave that. They could even, in monkeys, change which was the alpha male of a troop by stimulating the right parts of the brain. So one of these guys, Delgado, was quite a showman, a Spanish guy. This is him in a bull ring in Cordoba, Spain. And you see he's got a cape here, and there's a bull here. He starts flapping the cape. The bull gets aggressive and starts leaning towards him. And you'll see this white bit on the back of the bull's skull is a radio receiver with an implant there. And in his hand, he's got this black box and antenna there. And as the bull starts charging him, he drops the cape and hits the button on his remote control, essentially, and the bull just skids to a halt. It skids to a halt because he's stimulating its fear centers, and the bull is now terrified of him. Okay? I'm going to show you a video, and I'll just have to caveat this with, this is from a French documentary in the 60s. So it's in French, and it's not exactly HD video. But you'll see the guy in the white lab coat is Delgado, and watch how the bull responds to him when he pushes the button. Okay? See somebody else warming it up.
Soyons sérieux.
And now Delgado's
Une
there.
carte de vœux sincère, elle vient d'Égypte.
The bull runs
Les
away
hommes
from
n'ont pas
him.
encore à domestiquer les taureaux avec des transistors, ont rapporté cette année sur la
There is no button push,
les
push
plus
button.
grandioses, domestiquer un fleuve. 1964, 4 jours de l'épopée humaine.
Delgado and Heath also did experiments in humans in psych wards when there were not many protections for people in psych wards back then. They tried to turn a gay man straight. They brought in a female prostitute. They stimulated the guy's pleasure centers in an attempt to cause a new association, which didn't work. They gave one person, one guy, control over the remote control, or the signal that sent doses of electricity into his pleasure center, and found that he would press it about 1,500 times a minute, about once every 2 seconds. We're not sure what's happening in between there. So Delgado went on from that to write a book called Physical Control of the Mind, toward a psycho-civilized society. And here he talked about, hey, we could really improve society by fitting criminals with these sorts of implants so that we could remove their criminal urges and make them better citizens and so on. And again, all the mind control conspiracy theories about the CIA and so on really stem from this work that happened partially under a CIA funding back in the day. Now the medical and scientific community's response to this is really creepy. And can we get on to some medical application of this technology instead, which is what happened. Now I know there's been a TV show called House. There's a doctor named House that solves incredible medical mysteries. The first Dr. House was a guy named Dr. William House. And what he did, of note, is he invented this thing, the cochlear implant. So I told you some people have no inner ear hair cells. A cochlear implant looks like a hearing aid, but it's not. It has a mic, great. It has a little computer that processes the signals, same. But it doesn't play sound into the ear after that. Instead, it directly stimulates the auditory nerve via electrical impulses on these electrodes. Now, the auditory nerves of each ear have about 30,000 nerve fibers. The first cochlear implant had 1 electrode. Newer ones have 23. So it's a huge mismatch in bandwidth, 1,000x. So you wouldn't think it could really work, but it actually does work. People with cochlear implants can understand what they're saying pretty well without lip reading, and the technology is getting better and better. So let's look at some of what that's like. This is a picture of an 8-year-old girl hearing for the first time. And now there are about 200,000 people worldwide that have these, and it's incredibly life-changing. Okay, so this is a short video of a 8-month-old boy hearing for the first time ever after the activation of his cochlear implant.
Here we go, it's coming back on. And he's back on again. See how he turns?
Hi, Jonathan. Talk for a second. Hi. Did you hear that? Hi, sweetie. Could you hear that? Hi. Hi.
You got that, Deb, right?
Hi, Jonathan.
So that's what it's like to hear something for the very first time.
Call that a late Christmas present.
And YouTube is full of these videos, by the way. You can find them up to people aged 29,
That's really good.
hearing for the first time. That boy, by the way, turned 5 years old in December, and he's doing great so far. Now, yes?
Question, have people that formerly could hear and lost their hearing had cochlear implants, and is the perception the same?
Yes, people who have had hearing and lost it have had cochlear implants, and the perception is not as good, because the cochlear implant is still a young technology. So you, for instance, the frontier, what people really want to get to is music appreciation. You can't really appreciate music with a cochlear implant right now. It's not enough bandwidth. But you can make out voices, which is very important. So I said in the requirements list, data in, right? I also said multiple data types. Audio is one of them. Another data type that's very important to us is video. Our vision is probably the sense that most of us would most like to keep or restore if we lost it. And we have done some work in restoring that. This is a picture that was on the cover of Wired magazine in 2002. This guy is named Ramez Naam. Jens is a Canadian guy. When he was 18, he worked on a railway, and in an accident, his pick hit a piece of steel when he hit the rock, and a piece of steel flew up and destroyed one of his eyes. He was an outdoorsman, didn't want to compromise on his lifestyle, so the next year he was out snowmobiling, and a piece of the clutch of his snowmobile flew off and destroyed his other eye, rendering him completely blind, which he was for about 20 years until this happened, which is that he has, in this picture, this CCD camera. It's a digital camera like you would anywhere else. It's 10 years old, so it's terrible, but there you have it. This wire is the data connection, which went to a computer worn on his waist, which then processed those signals, changed the encoding to something else, and sent the data back up along another wire to a jack in the back of his head.